89 tutorial on how to use and find the inverse function for distribution function for your TI-89. So the TI-89 has the inverse norm, the inverse t, the inverse chi-squared, and the inverse f. What you need to do is find your stats app. So I'm using a TI-89 titanium. So when I go to my home page, I used the home button, and when I used that, I got back here and I found my stats app. So I'm just going to hit enter to get in there. You might have a different TI-89, and you can hit your apps button and find the stats app. Once you get to the stats app though, you should be here. So it should say lists, and then you should have up here in your functions, you're looking for the one that says dist, D-I-S-T-R, because that's your distributions. So it's F5, I'm going to hit F5. And what I'm doing is I'm looking for the inverse distributions. And now on an 89, whenever it has that, you're just going to click over because it's basically like a folder. So we're going to look at the inverse normal first. I'm going to hit enter. And remember, the point of an inverse normal is for, excuse me for just a second while I take this away, it's for when you're doing a confidence interval, right? And let's say I want to do, let's say I want to use a confidence interval of 95%, and I'm only doing 95% because we all know what the answer should be, and then this way we make sure we've done it right. Well, that's great, except the TI-89, like many calculators before it, only do what's referred to as a left tail. So it actually wants to know the area, not for the middle part, but for all of it. So if this is 95%, notice you have 5% left over to split between the two tails. Well, that's 2.5% for each tail. So really, this area from here all the way to infinity isn't 95, but it's 97.5%. So that is the area I need to put in, is 97.5%. I need to do this little bit of fancy footwork to be able to use my TI-89. And honestly, most calculators, and you have to do it this way. There's very few calculators that just calculate that middle area for you. It's easier for them is why they do that. So here, instead of 0.95, I need to put 0.975, because that's 95% plus the 2.5% in the left-hand tail that I'm looking for. Now, generally, if you're just looking for your z-score, in general, then you're going to do it on the standard normal curve where mu is 0 and sigma is 1. I'm just going to hit enter, and that should pop up my new screen, and you'll see that my inverse, this is telling me what my z-score is 1.9, and you say, oh, it should be 6, but look, it's 5.996. That is exactly what it is. So when you see it in a table, that rounds to 1.96. And that gives you, it reminds you, hey, that's the area you asked for, and you asked for it on the standard normal curve. So this part right here, this 1.95996, that is my z-score. If I wanted to do it for a t, I'm going to hit enter. Okay, if I wanted to do it for a t, go back to F5, go back to inverse, go back to inverse t. The only difference that I need is that it's always standardized by its degrees of freedom. Remember, how do you find the degrees of freedom? Well, that depends on what your sample size is. If we're just doing a single mean, then that would be on how big, it would be one less than your sample size. So in this case, degrees of freedom 4, while they only have 5 things in their sample. So let's say I had a sample of size 30. If I had a sample, if n equaled 30, that's 3, 0, that's if n equaled 30 and I was doing degrees of freedom for a single mean, then my degrees of freedom here would be 29, and I'm going to hit enter and enter again, and then it's calculating it. And so now my inverse, my t-score is 2.04523. And I had to do the same thing. This is still for a 95% confidence interval, because again, it's doing exactly like what I did for my inverse normal, and it's just calculating the whole left tail. So make sure that you're adding in this last part, that left tail.